All right, starting now. If anybody has any questions on Kyle's content, we can do the discussion through Twitch or through Discord. Kind of like how you've all been interacting with me. You can just type your questions out, and hopefully it should be interesting. So he's going to be talking about procedural generation, which is a very, very cool topic. If you've ever played any game where it's not like predefined, preset assets in a particular location, it's going to be generated by an algorithm. It's that kind of a topic, and we'll see what he has to talk about, but it should be quite interesting. I've started dinking around with a little procedural generation in Unity, and if we get through everything today, not sure that we will, but there are some interesting gotchas with Unity and using the default rigid bodies, physics bodies, that kinds of thing that can really make your performance just die, especially if you're throwing hundreds and hundreds and hundreds of objects in a scene at once and not really tweaking them at all. So we'll be taking a look at that a little bit later. Other than that, so then after his talk is done, we will do an in-class lab type of assignment. So it will be, depending on how long his talk goes, 30, 45 minutes, however long it takes, plus time for questions. I will basically plan to, well, honestly, what I will probably do is I will walk through the lab with you guys. So I will stream myself doing the lab manual, and then you all would have basically that's the rest of the time in class to ask me questions through Twitch or Discord. Once I'm done with the demo or with the lab content, I will probably shut the stream off. So if it takes me, 10, 15, 20 minutes to do the content, I would just shut the stream off and kind of idle either in the Twitch chat or the Discord chat, depending on what you all feel is going to be better or easier for you. So that's basically to avoid dead air, because I think just me on camera here sitting quietly for an hour would be kind of off-putting for a lot of people. I'd probably just stare at the camera intently, and that would be about it. But anybody have any questions? Anybody have any issues downloading and installing Unity? Anything like that? Or I guess any questions in general if you're concerned about your presentations next week, the week after. No, and if not, cool, cool, cool. Oh, we have 9 people in the room, 2 more than usual. Gotta get my subscriber count up. All right. And again, if you have a question, as always, I should probably put this in like a little info box on the bottom. The command is redeem, raise hand, and then tails is going to pop up, catch my attention. So just in case you've forgotten. Anyway, let's go ahead and get started. So this is going to be an overview of scripting in Unity. Today is going to be fairly demo heavy, just to warn you. So the odds that something breaks or goes wrong is fairly high, especially live on stream. You're all aware of how well my demos go in real life, so I'm sure streaming while having seasonal allergies hitting me is going to go very well for everybody. More information than everybody needed to know, I'm sure. So last time we kind of just did an overview of Unity. We didn't really dip into the scripting side of things, mainly just used, the environment and pre-baked assets or actions to really facilitate things. Where Unity really shines is in the scripting environment. So obviously the framework, kind of this nice little scene view that we have here is wonderful. Lots of power in here, but the back end is where you can tweak things. So The language is C sharp. It used to be you could do Boo or JavaScript, I believe. I'm not sure if that's still the case, but the default is now really C sharp. Um, if you have never done C sharp before, don't worry. I assume at this point you've all probably taken the Java classes at Oakland. Um, so if you're familiar with Java, you basically know C sharp. It's Microsoft's version of Java, at least to me. They use the class-based infrastructure. Um, packages come in via using. It's a little bit different, so obviously there are tweaks for Microsoft, but you should feel very comfortable in this environment. And honestly, the things that we're going to be doing with Unity, um, there really shouldn't be any concern about, not understanding the language or anything like that. So it should be fairly straightforward. And we'll kind of go into that as we go. And any of the labs that I'm going to have you do, I will walk you through the syntax because I'm not expecting you to, already know C sharp as a active developer. I mean, the last time I touched C sharp, I was doing probably my master's thesis in the late 2000s. And I could pick it up very quickly. It's like any programming language, you can pick it up if you just kind of figure out the syntax as you go. Really not too bad. So, scripts, what do they get us? In terms of Unity, what we're going to do is we're going to add customization to the various objects in our scene. So we're going to enable behaviors to be defined. So for instance, like our animated sphere from last class, we could add scripts to, have the player control it. We could have it bounce off of walls a little bit nicer. We could have it do a barrel roll around the scene. We could basically tweak its rotation parameter if we wanted. So you have direct control over all these assets. You can interact with them, as I kind of mentioned. You can take in input from the user via their keyboard, their mouse, a joystick. You can do some touch work if you have a touch screen or you want to support mobile devices. There's basically a lot of options there for you, which is very, very nice. And as we kind of go through this, I've got links to the various documentation pages in Unity. I would highly recommend becoming familiar with those if you are into the idea of using Unity. Basically, there is a plethora of well-defined information on their website. I don't remember what the keystroke is offhand, but at least in Visual Studio or Mono Develop, you can highlight a command. I think it's like Control, comma, or something like that, but it will automatically take you to the Unity website for that. Um, just to kind of give you an example of Unity scripting. I figured I'd have that link already baked in there, but there's this lovely documentation page, basically, for everything that you could possibly need in Unity. So if I wanted to look at, say, inputs. So for instance, input.getAxis. This is going to be a way of handling, which axis that you're trying to move an object on, whether it's up, you're hitting the up and down keys or the left and right keys. We're actually going to be using these later on to move a ball around the screen. But there's an entry for pretty much everything in here, and it's actually pretty easy to understand, which, if you've ever read any technical documentation, that's not always a guarantee that it's useful. So for these scripts then, what our process is going to be is we will create a script in Unity. So basically you're going to define a C# script in there. And the important step then is that you have to attach it to a game object. Otherwise, it doesn't run. Okay, so you can create as many scripts as you want. They're just going to float there and not do anything until you call them. They don't just automatically run. And then after that, we're going to be able to set attribute properties, which is where the power of some of the interaction between Unity and C# is really going to shine. So I'm going to be using VS Code for this. And I will say already to warn you that I've got some default settings in there which irk me, and I've just forgotten to turn them off. One of them being auto completion. So if I have a lot of compiler errors, it's probably because something auto completed incorrectly. And with this, so if you are on a Windows machine and you have either installed VS Code or Visual Studio, when you open up a script, it will automatically pop open into one of those environments. If you are in Mac OS or Linux, it's probably going to be mono-develop. I don't have either of those environments set up for myself right now, so I'm going to be using the Microsoft tools, but this is a cross-platform development tool, so you should have a fairly easy time getting this set up. And like I said, I've got a link here, various links to the Unity documentation for getting you up and running. And one of the caveats that I've got with VS Code and Visual Studio, I can't seem to resolve this. If anybody has any good suggestions or knows how to fix this, I would definitely be open to it. But I can't get my IntelliSense to work, so this is going to be I'm gonna basically have to go from a script of my scripts, basically, to show you what I'm doing here. So, like, I would expect to be able to type game object or rigid body and see it pop up with all the attributes and methods that I need, but I can't seem to get the hooks to work properly. So if I figure that out, I will share that. I know there are lots of blogs and guides out there for getting it running. I know there was a bug in Visual Studio 2019 that prevented it from working. A lot of the suggestions were to go back to 2017, and I think that still didn't work for me. So I'm just going to do my best, and I would suggest you guys do too. But if you want to get this set up, so let's see if I've got... so I need to add a script here. Let me just kind of get one going, and then we'll kind of walk through it. So I'm right-clicking down here in the assets area, create C# script. Let's call this hello world. So we'll just do a basic hello script. I'll probably mention this several times, but it's good to keep your project well organized for any Mac users out there. Okay, so there's a Mac VS 2019. That's pretty cool. Oh, there you go. Honestly, I will say this, Visual Studio is a very good development environment. So I used to use it a lot when I was working. And it's a big environment, it's a big framework, but it's actually pretty well put together. At least for doing C, C++ development. All right, so I'm going to create a scripts folder, and I'm going to drag my script into there. So basically, I'm going to keep all my scenes in the scene folder. I'm going to keep all my scripts in the scripts folder. I'll create folders for materials, for basically everything that I do, just to keep things organized. Because if you're building a big game, organization is going to be key, and having intelligent naming schemes is also going to be key for you. So I've got the script here. And the thing that I was mentioning is edit preferences. So it's going to allow you to pick which tool you want to run by default. So I've got Visual Studio Code here. By default, it's set open by file extension. So it's whatever environment is going to be run whenever you click like a .cs file, for instance. You can explicitly set it in there. I'm missing, maybe, okay, so these are just the basic tools. I'll have to look around in here too, maybe the IntelliSense issues in here. But edit preferences, external tools is where you can set this guy. So, yeah, and then here's basically the guide for getting IntelliSense working, which didn't work for me. Okay, so this is where I'm at so far. So I created a scripts folder. I created a C# script. I double-clicked it. Actually, I don't think I did double-click it. I'm going to double-click it now. Double-click. It's going to pop open VS Code. I've turned off the explosions for when I type in code as I go. If you've never used VS Code, it's very light. It's a nice lightweight development environment. I actually kind of like it. So it almost seems to be like a blend of Sublime Text and Visual Studio in a way. I've also noticed it tends to get quite laggy at times as well, so take that for how you want. I did install the Unity plugin, so I'm not sure what's going on. My laptop is in a very odd state right now too, I should mention, so there's lots of oddities going on with it. Like I said, if I figured out what's wrong with my setup, maybe it'll help somebody else. The standard, the standard methods out there will probably work for the majority of you. Anyway, so here I am in this project, so I should probably close this since that's a different thing. This is going to be your basic script that you see when you create a new Visual Studio, sorry, a new Unity script. So we have our class. We have a start and an update function. We have some using calls up here. Basically, this is going to come in by default. These are your standard namespaces, libraries that are needed by this script. We can add whichever ones you want to extend it. For instance, if you want text elements, you're going to have to include unityengine.ui, for instance. So yeah, basically we have that here now. So just to, maybe I'll just use the code here. So public class, so basically this is the class specified for the particular script we created. Note that the name of the class matches the file name. This is required. So if I wanted to change this class name, I'd also have to change the script name from hello world to whatever I want it to be. Otherwise, you'll get a compiler error in Unity. This is a mono behavior. So we're basically extending this mono behavior type here. If you're going to be generating any kind of Unity scripts, this has to be there. It's placed there by default, so you don't necessarily have to worry about it. We're not going to be getting into all of the different like extends and implements, all those interfaces. We're just going to use this by default here. All right, a couple of other things that we see. So we see the start and update functions that are automatically defined. There are several others that we could use, but they're not placed there by default. So start is the function that gets called basically when the object is instantiated. So if I have a cube that I've placed on the scene, start would be called the instant that it is, popped into existence. Update's going to happen once per frame. So basically every single loop of our program, update will be called. All right. And there's going to be places where we use update and places where we use some other functions too. So for instance, and this is going to be a little bit different. So if you are used to C#, this code is going to be slightly different than what you're expecting. So for instance, if I want to print out a statement, I just call print. I wouldn't necessarily call console.writeLine. So let's say print hello world. So we have our basic hello world program here. So easy enough. When this script is instantiated, I should see hello world in my console. So things to note here, all I've done is I've clicked save. I did not compile and build this thing. We are just going to use the development environment for its IntelliSense features, assuming it worked. And again, that cynicism, snarkiness is aimed at my personal setup, not everything else. And there's a lot of people that have this working. But Unity is going to be handling the compilation. So I'm going to tab over to Unity. You see my cursor has gone to an idle state. It's basically building. If we had an error, you would see a little red, basically a little bit of a red error message here at the bottom. Everything worked okay, so life is good. Other things to notice too, so I've got the script selected. You see over here in the right in the inspector that my code is actually listed out here. You can't edit this. This is just a preview of what's inside the script. All right, so life is good so far, so I'm gonna hit play. And away we go. So if I wanted to see the output, I would look in console and I should see hello world. I do not. Does anybody know why I don't see it there? Assuming we're all still paying attention. It's not attached to a game object. Hey, I've got a sysadmin person in here. Awesome. Hello. Yeah, exactly. So I didn't create a game object, right? Scripts have to be attached to something. This is one of the cool things about Unity, to me, that there's this way of attaching objects to each other. I've been trying to pick up Unity for years. Well, I do have two objects. I haven't attached it to anything. That's I could have them attached to that. Thank you. Um, but being able to attach objects to each other, for some reason, it just took a while to click for me. All right, so we don't have it. We need to save, obviously, so I should probably have mentioned this. Also, before we go into attaching things, make sure that you save your scene. Tiny little emoticon there. Thank you for the facepalm. Expect lots of those. You've had me for a couple classes now, so, or at least 1.5 classes, so facepalms are worthy or common. But with Unity, you want to make sure you save the scene often. So if I make any kind of a change in here, so let's change this light to, red, for instance, or pink, the scene would get this little asterisk up here and up here. It's not going to necessarily auto-save for us. You want to make sure that you save often, save often, save often. I'm not going to be able to say that enough. All right, so back to the scripting. Nothing happened because we didn't attach it to anything. I could attach it to one of those existing objects. Let's create a plane because we're going to need this eventually. So let's make a plane. So we can also rename it to be floor because we'll use this later on. And since this is our initial, basically our initial object here, I'm just going to drag and drop my script onto this object. You see it pop up in the inspector here. I hit play again. And we should now see, actually, we got a little message there at the bottom, but there's my hello world. So important things with scripts, again, make sure it's attached to an object, otherwise nothing's going to happen. All right, so basic hello world should be hopefully fairly straightforward. And as we get into the scripting, we'll notice that whether objects are public or private is going to impact what the Unity interface actually looks like too. And one thing I should mention here as well, before we get into it, so this script, it really didn't do anything important, right? But if this was a script that was, say, instantiating our scene or, maybe controlling an object, you want to attach that script to whichever object it's going to be interacting with. It should be fairly self-evident, but you don't want to have your player controller object attached to the camera, for instance. You could make the links between the player object and the camera and do all of the fun calculations and all that. But usually it's good to, again, keep things well organized, right? So these scripts, I've got some definitions here. So basically, we've already talked about we've looked at the class declaration. So again, this is very, very Java-like. Start and update we've talked about as well. Thing with update is that, just to clarify a little bit more, it's going to run as fast as possible. So if I constrain my program to a particular frame rate, update is going to try to run basically as fast as possible within that context. But we have some other update functions as well, which we'll get into in a little bit, whether it's updated after everything else has been updated or if it's updating on some kind of a physics-based action. So use update when you want to basically, update various states of things, but you don't necessarily care about like physics interactions, or you don't care about everything having completed its tasks, if that makes sense. So it's just like a general update. All right. To talk a little bit about the types and scope that are available to us. So again, very Java-like. So you have your standard types like int and float and char and string and all of those, char and string. Scope should also make sense too if I define a variable inside of a block. So for instance, if I created int test equals 0, this variable would only exist in the start function, right? It would not be accessible by update or any other function that I create. If I want it to be globally accessible, I would put it out here and say public int test, tset test. And then in start, I would initialize it to be 0. Right, so this public variable would be accessible anywhere. Right, so I'm going to save this. And we're actually going to see, so as soon as this is done compiling here, that test variable appears here in the script. So it's initialized to 0, but I can change this to be whatever I want right here in the interface. This is wonderful for testing and debugging your program because I don't have to go back into the script and reset the variable and, basically recompile it every time I want to test something out. I just have an attribute here. And you think, well, we're programmers, who cares? Right? But think of maybe the game designers who are just using the Unity interface. They don't want to get into the C# code, for instance. Or again, you just want to make your life easier and not worry about redefining basic definitions. You just do it right in the Unity editor. Now, if I had made this private, private means it's only accessible to this class. So again, hello world only for this class here. This variable is going to go away in the editor here. So my test variable has disappeared from my script. It still exists. I can still use it anywhere inside the class. It's just not publicly accessible. And we'll leave the discussion about whether you should make variables public or private to your software engineering courses. Again, feel free to ask questions as we go here. Other things you might need to know: operations, equality, so on and so forth. If you know Java, C++, Python, you're going to be fine. If statements, loops, these are all basically the same. Only thing to keep in mind with C# is the types have to match when you do an equality. So for instance, you might have an issue trying to see if a string is equal to an int, right? You probably have this in Java. I'm not a Java developer by personal preference. But for instance, if I wanted to check if a string and an int match, I'd have to cast one to the other's type. So I'd have to turn an int into a string or a string into an int, or both of them into a float or something like that. So loops, if statements, decision statements, branching, all of that kind of fun stuff, it all exists here. Syntax might be a little bit different than what you're used to, but it's pretty easy to pick up. So operations are what you already know. Not going to really go into them because it's just basics of the language here. What's more interesting, though, are some of the Unity specific functions that we also have. So we had start and update. So I've got these guys here. There is one thing that I haven't mentioned with start, though. So start is called if a object is both instantiated and enabled. Okay, so what enabled means is that, let's say that I drop in a cube in here, or maybe let's do a sphere. Actually, so I should reset these guys to origin. Reset to origin. So we got our sphere picked. Just to make sure we're at 0. Let's move you up by 0.5. One other thing I should mention before we get into this too much: objects in Unity have a default size of 1. So this has a diameter of 1. Cubes have a width and height of 1. So if I bump this y value up by 0.5, it's going to be resting neatly on its plane. Right? Double click it to go back to its reference. But where was I? Enabled. Okay. So in the inspector here, we see our sphere and we see this little checkbox. Okay, if I click it, thing disappears. I do the same for the floor. Disappears. I can run this now, and we shouldn't see our debugger output anymore, right? Because start is only called when objects are enabled. So this is a key distinction here. If an object is not enabled, it basically doesn't exist for start. Okay. You would enable or disable objects if you don't want them to appear. If you want to be doing some debugging, like maybe I'll disable all of the collidable objects and just have my player roam around the environment, something like that. So think of it more like either a debugging thing or I want to hide an object until I need it kind of a thing. But start's only called when both these cases are true. Now, if you want to still work on the game object, if it's disabled, you would call the awake function. So this would be void awake. This gets called when it's instantiated, but not necessarily enabled. So if you wanted to ensure that some variables get initialized, you would call it on awake. More or less, you'll probably use start since the objects you create should be enabled anyway. As long as that makes sense, but slight distinction there. Okay, and then update we have already talked about. but to give you a little bit more information about that, these tend to be good for like constant updates. So if you have an animation frame that has to be advanced, or you have an AI decision that has to be chunked out, so you might call that in awake. We have a couple of other functions too, which work on a frame-by-frame basis. So there's fixed update, and then there's late update. And we're going to show examples of both of these here fairly soon. So if you have any physics operations that you want to perform, so you have two spheres that collide with each other, and you want some action to occur when they collide. So maybe they collide with each other, and instead of just a normal, we're going to let the rigid bodies handle it, I want them to go flying off into space. Or maybe I want ball 1 to turn green, ball 2 to turn purple. I don't know. You'd call that in fixed update because this is basically where all the physics examples are happening. I'm not going to go into great detail on this one. I've got a nice little tutorial here about the differences between them. So again, Unity website is awesome for documentation. All right, and then the last function is late update. This gets called at the very end of the frame. Professor leaves mouse on screen and annoys students. Volume 2. Okay. So what this means is that during each update cycle, Unity is going to look at all of the game object update functions. So that void update gets called for every single game object, and then late update gets called. So for instance, here I actually have a quote that I pulled right off the Unity site. So I'll let you read that, but basically what late update becomes is a secondary loop for you to work with. So again, after everything is completed, then late update runs. All right. So there are going to be use cases for all of these functions. That's why they exist. And we're going to try to work with all of them as we go. All right, anybody have any questions so far? Everything making sense? More or less, anyway. Thank you, Paparuski. It's much more fun to refer to you to your anonymous online names than your real names, right? They're more personal. Okay, so with your C# classes here too, we're not going to go into them. Again, I'm going to assume that you can pick them up. You're all juniors, seniors here at this point. Just a couple of things you have to worry about with these guys. So the class name has to match the file name. This exists in the Java world as it does in the C# world. However, it's very easy to want to change your class name inside Unity. Make sure that your file name matches if you decide to update something. So for instance, here, this fixed update v update. So this is basically a, actually it's a class name from this tutorial. It prints out various timestamps here. It should match, basically. And another thing you can do too is you can define a custom class. So for instance, if I create a new script and it's going to be class, fixed update versus update, I can add extra classes on there as well. All right. So it doesn't have to be the exact same one. I could create, another one that's going to manage another aspect if I want. Make sure that it is serializable. So you have this little modifier on top of the class definition. Otherwise, Unity is not going to be able to pick it up. All right, so I actually have an example here that we can do too. So if we pop back over into our class definition, so I've got my variables. We're going to get rid of this test variable just to not confuse things. What I can do is I can create a new class, a public class. I am a tester, AMA. So straight up normal class, all right? And then we'd say I am a test. So we'll create this constructor, print, hi there. Exclamation point, because we're excited. And so we have this class, right? And then we can also set a public int AMA var. that's dumb. CSI4900 var. Great. So CSI4900 var equals 4900. Grade variable. Hi there. Plus CSI4900 var dot to string. Okay, so what our constructor here is doing is, this is a standard class definition, right? So I have a constructor. I don't have a start and an update because this is not a mono behavior class. Straight up normal default constructor for any class. All right, and what I can do in here now is I can say public IMA test. This is getting to be annoying to type out. Local test. Let's be lame with our naming. All right, so I have a reference to this class. All right, so this points to here. I have a local instance of it, and we're just going to let it be created. Okay, let's see how many things I've broken in Unity so far. Name print does not exist in the current context. All right, because it says not mono behavior. We want debug.log. I think log is capital. Right, because print is also part of this mono behavior extension. I forgot about that. Now we say that debug is not found. All right, good. So run our program. We see hello world. Should be seeing hi there, I think. No, we have to instantiate it. Local test equals IMA test. We have to do something like that. Inaccessible. What have I screwed up here? Should be all public, public, public. There we go. All right, kind of zipping through some demo code there. Yeah, so okay, hi there, 4900 pops up. Perfect. What I forgot was to make the constructor public. So this needs to be referenceable outside of this class, basically. So what I did, just to run you through that, so I created this public variable here. I instantiated it in the start function, and then this calls the constructor saying hi there, CSI4900, so life is good. What I want to do, though, is I want to see in my script here, I don't see any of my variables pop up. Again, what we have to do is we have to turn this into system.serializable. So just add that tag on there. And now what we should see, did I forget a semicolon? Oh, I deleted it somehow. That's not smart. Don't delete your semicolons. They're useful and necessary here. What I see is this reference to my test variable. If I change this to 5900, let's see if that picks up or if I have instantiated it in the wrong place. Yeah, so I clearly didn't set that up right, but point is that basically I'm overwriting this value when I instantiate the function. It is now publicly accessible to everybody. So we can... but does this all make sense here? I'm just going to go ahead and comment this out and use this as kind of a live demo here. Away, comments, comments. It's going to get very quickly confusing, so I'm just going to get rid of those guys. All right, whole point of that demo, again, if you're going to define a class and you want it accessible to the Unity interface, make it serializable. That's probably going to be useful too if you need to like save state your game or anything like that. Serializable and make it writable to a file later on. Makes sense. Well, yeah, I mean, the two of you that are actively doing Unity, this should all be probably review. If anybody else is struggling with Unity, again, please pop up and let me know. Okay, so moving on then. If you want to get a press of some kind, so like a mouse button press or a key press or anything like that, we're going to handle it in the update function. So for instance here, if input.get button down fire 1, so basically once I click my mouse, it's going to log the position. So get button down is when you press it, get button up would be when you release it. All right. So here, let me get my editor back up. So I'm just going to keep using this hello world class here. So in my update function, I'm going to add in if inputs dot, this is where IntelliSense would be useful, get button down fire 1. You'll notice that it's a string, so it's just looking for basically whichever event is tagged with fire 1. Debug.log input.mouse position, and mouse is lowercase, p is capital. Okay. I could have done print since I'm inside this class, but I'm just going to debug.log it. So again, I saved it. It's going to recompile in here. And we play. Click. So we see the XYZ coordinates of my mouse cursor in relation to basically a 2D surface here. All right, so again, that's get button down. If I play this again, sorry. I'm holding my mouse button and nothing's happening if you're noticing. Basically, get button down, get button up are called once per frame, and it doesn't clear until you release that action. So if you want to do a repeating key press, we'll look at that in a little bit, but it's basically a slightly different function call to this. So if you want to like hold down the mouse and have your character just shoot off a million bullets, you need a different way to do that. But we'll get there in a moment. Very, very quickly, actually. So we used get button down. So get button down mouse, also going to work with the joystick. These names of your buttons or, whichever attributes you want to check are listed out on the Unity website, basically. I've got a link in, oh, thought I had a link, but basically it is up there if you need to look up which key is which. All right, so here I've got a little bit of extra code for handling key down and key up. So last one was mouse, this one is a keyboard button. So we can leave this guy in there. So if input dot get key down, down, key code dot space, debug.log space pressed, and I can copy and paste this, get key up, space released. I've got the Vi extension installed into VS Code. That's why I kind of have it set up to my liking right now. All right, so get key down, get key up. Key code.space. So there are various functions for getting the key. This basically is like key code dot whichever key you want to look up. This kind of thing is helpful if you want to basically remap keys later on too. All right, so we're compiling. Save my scene. I'm going to save my scene. There we go. Still over ball. I'm going to hit space. I'm holding it down. And I'm going to release it. Space press, space released. Again, it depends on what action that you want to provide. Do you want something to happen as soon as you hit the space bar or when you release it? It's up to you as the designer of this program. Now, let's say that I want it to be repeating. So the action is instead input.get key. So it's not key down or key up, it's just get key. So let's say if input.get key, key code.p, debug.log p held. All right, so I've got key down, key up, get key. All right. We're running. I'm holding down the P key. You can see it just continually going and going and going. So again, this can just go right in the update function. Should make sense more or less. Now, everything we've done has been in terms of the mouse or the keyboard. If you export your program to something like WebGL or Android or Apple or anything like that, you're probably going to have to handle a touchpad. Well, not a touchpad, but like a touch-sensitive surface like a smart screen or a tablet or anything like that. You're going to find that key presses don't translate to that format. I've got a link to a tutorial here if you want to go ahead and do this. It's not necessarily, it's not a quick and easy demo. That's why I'm not going to do it out for you here. But if it's something that you want to support, it's really not that hard. You just have to do some conversion between, where you press, or if you want to make like a virtual D-pad where you can have your tablet or your phone and you can, use left, right, up, and down, basically tracking a picked point kind of thing. So, this might be a good time to talk about some of the Unity tutorials as well, because they're actually all very, very useful. So they have a bunch of these like little handheld tutorials for walking you through doing some task. So here is touch input. So they kind of have this nice little code lab style, breaking it down into steps for you. Some of them will have videos, some are just code. But for instance, here it just walks you through, am I doing a long press? Am I doing a short press? What code do you need? What attributes have to be set? And again, just kind of walking you through this whole process. And here we're handling multi-touch. So lots of cool things you can do with that. Yeah. And then here is a get reference guide to basically all of the inputs that you can have. So again, definitely recommend getting familiar with this interface for documentation. It is, it looks maybe a little bit cumbersome or maybe even hard to understand if you're not used to looking at documentation. But if I need to get input, here's everything that I need to know about input plus an example. I could just copy and paste this get button down, change the insides here to whatever I need, and then I've got a pretty easy and straightforward way of having, mouse input here. But I could like get the acceleration of the mouse, for instance, or does the mouse exist? So lots of cool things in there. All right, the end breathe wasn't for me, it was for you. I didn't realize I was taking a deep breath until it popped up, but any questions so far? So we've got defining our scripts, we have handling input, attaching scripts to objects. And we're going to start getting into a little bit more deeper things here. All right. Well, assuming everybody is good so far, we'll talk a little bit about frame rate. We'll talk a little bit about sound. Again, the whole point of this lecture is to just kind of give you a smattering of how some of the basic scripting elements work. I'll walk you through the Rollerball tutorial that is up on the Unity website. Basically, I mentioned it's for videos. It's actually for components with several videos per component. So I'm going to kind of give you the Cliff Notes version of a very quick and dirty tutorial. And then we'll look at maybe another project too. So first one is frame rate. So I kept forgetting to show you all how this worked in WebGL. But if you want to set your target frame rate in Unity, it's a very, very simple call. You just call application.target frame rate. You set it to the value that you want, and Unity will do its best to make that happen. All right, so the thing here is that there's not a guarantee that you will get that frame rate. All right, so I could set the target frame rate to 300 and say, run as fast as possible, 300, you know, 300 frames per second. Right. So this is going to be reliant on my processor. I can try to lock it to 60 frames per second. I can try to lock it to 30 frames per second. The key here is going to be that your program is optimized in such a way as that Unity can attain this. So if I throw 5 million cubes into a scene with rigid bodies, with spherical or cube colliders on them, Unity's got to do all of those calculations every single loop, and this frame rate's not going to be achievable. So it will still be up to you to make sure that this frame rate is achievable by Unity. Other thing too, so you can set this to be -1 and just use the default value. So whatever the target environment's default frame rate is. So for instance, if I build towards WebGL, the default frame rate is going to be whichever browser you're using has set for that environment, whether it's like Firefox or Safari or Chrome. They might have different frame rates they lock to. But what we can see, and actually I will pop open a fully working project to demonstrate, hopefully. This is basically what we're going to be getting to towards the end here, I hope. Unity taking forever. How's everybody's online classes going so far while we wait for this to pop up? Life good, more or less, I hope. WebEx sucks. Yeah, that's why I've avoided using WebEx. This is the only lecture you've got, huh? Interesting. All right, so I'm not going to show off all the fun stuff in this project so far. This is basically what we're going to be getting to. Podcast style. Ooh, guy must be cool. So this is the rollerball demo with some little tweaks by me to make it a little more interesting. But you can see the ball moves fairly smoothly, assuming that the stream is doing it okay. I'm gonna go ahead and stop you right there. So let's open up this script. Sorry if I'm sniffling. Allergies are killing me here. All right, so player controller. And where is my... So here I've got the target frame rate set to 30. So this should be running at 30 frames a second. I can change this to 3, for instance. Save it. This will rebuild. And if I run this now, it's going to go really slowly. So I'm getting 3 frames per second here. So it's not your stream that looks terrible. This is actually the program. So again, setting your frame rate to something appropriate is usually a good idea. Now, if you don't set it, it's just going to run as fast as possible. It's going to use the default value. I'm going to minimize this. And do I have 2 VS codes? Yeah. All right, so minimize that. And now we should be back to our hello world again. So, most games are either set to 30 or 60, depending on your application. 30 is usually fine. Leaving it as default is fine for the majority of the applications too, if you don't necessarily care about frame rate. All right, another thing that we can do before we get into ball rolling is talk about sound. So sound is fairly straightforward, at least if you're doing basic, simple sounds. If you're getting into things like ambient noise or you want to do left versus right stereo sound, that's basically you're getting a little bit deeper in there, having sounds get louder or quieter as you approach something. Leave that for a more advanced Unity implementation. But if you just want like a little bleep to happen when an event occurs, or you've won the game, play the win sound, for instance. That's actually really easy in Unity. So like with our materials and all of that, if we want to import a sound, we have to import it into our project. We also need an audio component attached to our script, and we then have to link them up and then call it through our scripting language. So now what we're going to do here, project. So let's add a folder for sounds. Pop on over to our assets store. So I have a sound. Search for wind sound. Use free assets because we're not making anything interesting here. So I downloaded this free music in SFX. Again, sounds are up on the asset store just like materials and prefabs and scenes and all that. So I'm going to go ahead and import this. And here's a whole bunch of various sounds that we can set. So I want a, let's see, human agony screams. That would probably be a good one if I wanted to wake everybody up. Let's go for congratulations. That sounds good. So let's import that one. So we see it pop up here in the free pack. So I'm just going to drag this into my sounds library here. Open this up, and then we see this guy. It's actually going to open up, I thought it would open up VLC. I guess not.
Congratulations!
Lovely. All right. So we have this object. Now we need an audio component for wherever we're calling it from. So here, my script is based on... You're speechless? That didn't take much. All right. So our script is tied to the floor, so we want the component on there. So I want an audio component. Audio source. So let's add that on. And then we get this little audio mixer. So the important thing here is the audio clip. So you want to drag your clip here. I could mute it. I could play when it wakes up. So I'm actually going to deselect this one because I don't want it to just play when the scene loads. I can set it to loop. I can set various options for the sound itself. But other than that, that's good for me right now. So let's save this. And now what we can do is, not sure why I have the screen. Oh, this was just the example. Okay, good. All right, so now in my script, I need to basically link that component to, to some local object and then be able to interact with it. So just like before when we were getting our cubes or getting our game objects, it's the same thing here. So create a private variable for our audio source. We will pull that component in our start location, and then we'll play it when we hit the P key, right? So this get component only is going to work if we have matched it up in here. So if I hadn't dragged this into this location, get component would fail. And for instance, if I had this sound attached to another object, I would have to do something like find object, basically. So there's a game object.find call where I can search for a named component, but we're not going to get into that right now. We'll talk about that and like tags a little bit later. All right, so here we go. So let's create a private variable. So private audio sources capitalized, audio data. All right, so I have my private variable. In start, I'm going to link it up. So audio data equals get component, audio source. All right, so there we go. So now I have pulled this component in. I should mention too that types have to match. So this is I think this is a Java thing. I know this is a C# thing, but basically I'm going to constrain the type that I'm looking for to be audio source. So we see those matching there. And we're going to pull that in. Okay, so now let's get rid of, actually, let's maybe make it W. So if input.get key up, because I only want this to happen once, key code.w. This really doesn't like indenting if you don't put the brackets in or curly braces, so I want to do audio data.play 0. All right, so it's just going to start at the beginning, play the 0th track, however you want to think of that. So I'm going to hit let it compile. Missing a semicolon. Awesome. Ooh, what happened here? Vim commands be bleeding through. Okie dokie. I'll play this. And P still works. Click, still works. Let's win.
Congratulations!
So I hit the W key and it just played. Again, Unity is facilitating loading the file into memory, handling the setup of the audio device, so all of the headache that you would have in a straight up procedural programming language like WebGL, OpenGL, STL, all the headaches gone. It's now a GUI component with a very simple scripting interface. All right, questions so far? Everybody good? So basically from here on out, what we're going to do is we're going to go through the rollerball demo. I'm going to do a very, very, very truncated version of that so you don't have to sit through, I think it's like 30 to 45 minutes worth of tutorial videos. If you get lost or confused, or maybe something I said is a little bit too high level, feel free to check out their videos because the guy goes through it very, very carefully to make sure you understand every single component. I'm going to assume that you kind of understand how these things all play together right now. So let's make a ball roller. I have a link to the tutorial here. Again, so if you go to the Unity site, they have a ton of videos. Definitely recommend checking them out. But this is the rollable demo. So it goes through the setup, it goes through creating the environment, creating the player, handling scoring, doing a build. All of that is in this tutorial series. And I actually have two versions of this, so please go away. So efredericks.net/ball is one that I made probably 2 years ago when I first started trying to learn Unity. And then I put Unity down and I forgot everything that I knew about it. And here we are. I've got a new and improved version of this too when we're done. So we get our nice little Unity welcoming screen because I'm just using the free version, but here is our target. It's got this nice little, actually I've tweaked this to horribly increase in speed every time you, I think, touch an arrow key. So if this is a little jarring, yeah, so then you get a nice little UN text here. So what we have, let me refresh this so it's not as seizure inducing. But I'm pretty sure if you pay for Unity, you can get rid of all the Unity loading stuff. Could make this full screen if we wanted. It's nice and pretty. But what we have our plane here in the bottom. We have 4 walls, which are rigid bodies. We have a sphere, which is our player. And we have a bunch of rotating cubes that are collectible items. We also have a score indicator up here. So this is a text element, and then you saw UN pop up once we picked up all the cubes. So some things that we're going to be looking at in here. So we're going to basically pull everything together that I've been talking about. It's kind of why I like this rollerball demo. It's a very cool thing that you can show off that you did in like 10 minutes, honestly, if you get the hang of this. But you have a 3D scene with a very, very simple game. And you could add, a whole lot of things to this framework to make it a little bit more interesting. So first things first, let's talk about what all of these little cubes are. So these are all prefabs. So this is actually I created a cube, I made it a prefab object, and then I duplicated the prefab. Prefab is super useful if you want to make lots of objects. So if I want to say create like a collectible pickup, apply a texture, apply actions, and they're all going to basically interact in the same manner. They might have the same collider applied, for instance. Um, I can just very easily duplicate them and very, very quickly have a scene full of little pickups here. Same goes for the walls. Now, the walls are not collectible objects, but they will cause the ball to bounce. I should mention that bouncing I don't have in this set of slides, so we might look at that later. The ball just kind of hits the wall and dies, so there's not like a bouncy property in the version that we're going to walk through. But basically what I did was I created one wall, set all the properties that I wanted, turned it into a prefab, and then duplicated it 3 times. All right. Other thing here too, so let's see if we can stop the ball. All right, close enough. This is a WebGL game, for lack of a better term. Very, very simple game, but it's still a game. All I did was I built for WebGL. So again, if you go to File, sorry, not Fun, I'm in the wrong spot. Class Demo. If you go to Build Settings under File, here's all your build targets that you can have. You can also pick which scene you want to build. You don't have to build them all if you have multiple scenes, but I can build for whichever platform I want. For instance, this one I picked WebGL, and I built it. And it created an HTML file. It created all the libraries and extra files and materials and all that I need, and I just pushed it to my web server. Things to keep in mind, if you build for WebGL, memory management is going to be much more important for you because there tends to be a little bit less flexibility between the browser and WebGL. I tried building some procedural environments, and WebGL very quickly ran out of memory. So there are some memory optimizations that I'm going to have to apply to make them even work for WebGL. You have a lot more flexibility with, say, PC, Android, things of that nature. But there are obviously you can compress things, you can reduce things to make it a little bit better. I'm not going to do the build because, as we saw last time, the build process will freeze the stream, and yeah, nobody wants a dead stream. WebGL does run slower than native too, so that's also one of the downsides. But if you optimize things, it does do pretty well as well. Okay, so what I've got so far, I've got this Hello World script, I've got my audio. I think what we'll do is we'll just leave this in here for now. So I'm going to actually rename this this script. So I'm going to change this to be, what have I applied it to? Floor? We'll leave it as Hello World for now. All right, so things that we're going to have to do here. We're going to have to create our environment. So we need the floor, we're going to need walls, and that's going to be our basic environment. We could have made the bottom a terrain. So if you remember last time we had that terrain where we made like hills and mountains and all that, I could do that. I'm just going to make a plane. So it's going to be a flat surface. We're going to apply a texture to it to make it look a little bit nicer. Then we'll create some standard walls. We'll create the player. So the player is going to be a sphere. We're going to control the movement with the arrow keys. If you want to get freaky, you could control the movement of the ball with your mouse and like have it follow the cursor, or use a touchpad or something like that. The way keys are going to work, it's not just going to be update X and Y. It's going to be applying forces to the ball. So we're going to make it a little bit more momentum based. Then we'll create our collectibles and track our score and have a win condition. So this tutorial, it's 3D, obviously, so you need the 3D space. First things first, so we need a plane. So I already created this, obviously, for kind of our walking demo here. So let me orient to our frame. So I've got my nice plane. I've got my player controller already here. I haven't done anything with them. other than add this hello world, so we can just start from here rather than wait 10 minutes for Unity to create a new project. Um, but this plane, this is just a 2D surface. All right, so there is no volume with a plane. I can't extrude the plane to make a giant cube. Um, so for instance, if I have this selected, if I want to scale X direction, I can see the X get bigger. If I scale the Z direction, I see Z get bigger. If I scale Y, nothing happens. If I scale Y to the negative, it disappears. But it doesn't disappear, it's actually flipped. So the front facing plane is on the bottom now. Let's go ahead and reset. Go back to the top here. And then we have our plane back. So again, keep in mind planes are 2D objects. Well, they're 3D, but they have no volume. So effectively, we have that. I'm going to scale this up a little bit. So let's make this 10 by 10. So we have a nice big surface to play with. I haven't sat down and calculated out the sizes of everything, so I could make this line up nice and prettily, but we're just going to make the plane huge. All right, other things though. So with our plane, it has no volume, but it still has a mesh collider. So we will have that. So for instance, if we look here at our sphere, it's got a sphere collider. Plane has a mesh collider somewhere, right there, mesh collider. When we hit play, nothing happens, right? Because there's no rigid bodies, there's no gravity being applied. But we can do, let's move this sphere up a little bit. Again, Y is the up direction here. And you see the little speaker icon. This is because I have a speaker or a audio source applied to the plane. Let's make this a rigid body. So I'm going to add a component, rigid body. I'm going to use gravity, hit play. Boop. No bounce, just kind of think of it like a lead shot hitting the ground. If you're a fisherman, it's your line weight just plopping down. We have a nice heavy metal object, for instance. So the plane will collide with objects, right? No volume, collider exists. Okay, so our player is going to be this sphere. So again, your player can be whatever object you want, but keep in mind that if you're going to use one of the primitives, it's going to have the default properties of that primitive. So if I added a cube and I start applying forces to the cube, it's going to react like a cube would. A sphere is going to roll around because it has a sphere collider on it. A ball is going to kind of scoot and maybe, roll around on its corners or its edges because it's got a cube collider on it. Right? So what we're going to do here is we're going to add our sphere. We're going to apply a rigid body, which we just did to demonstrate things. And then we're going to move it up by a half because, again, this has a diameter of 1. I moved it up for comedic effect. So let's put it back down to 0.5. Great. So we have our sphere. Good time to, as I mentioned in the slides, so let's keep things organized. So we'll call this the player. Our floor has been named the floor. We like that. What we have right now is a sphere, which is not going to move anywhere because we have a perfectly flat surface. Okay. So what I could do if I wanted to be cheeky, let's take our floor, let's rotate it a little bit. So now we actually see kind of a distortion. Well, the rotation. And we can say goodbye to our ball. Actually, it's just going to float through space because it's no longer oriented on the plane. So our ball is just falling. Let's reset our plane. I keep mentioning this notion of resetting. So there's this little 3 dots on transform reset. That will get you back to a standard state. Now it also will reset the scaling. So I'm going to have to go ahead and fix that. Let's say this was what, 10, Y is 1, Z is 10. All right, so our plane is back to normal. I'm going to save this to make sure I don't lose anything if it dies. All right, so we've got the player. So this is basically where we're at. Um, this screenshot here, if you're following along in the slides, I've got the Y a little bit too high. That was just to demonstrate it higher or lower, but straight up scene. Okay, now let's make this look a little bit nicer. So let's add some material. Let's add some texture to our scene. Okay. So I want some materials. I want the plane to look different. I want the ball to look different. Um, Basically, I want things to look nicer. So let's create a materials folder so that we can organize all of our materials. And then in here, so I've double-clicked the materials folder. I'm going to create material. So we'll call this floor mat. So let's make the floor, could do a nice royal blue maybe-ish. And I click this little circle next to albedo here, and let's give it a test pattern just to give it a little bit of pizzazz, for lack of a better term. I'm going to drag this texture, or this material, onto our floor. And hey, look at that. So this albedo mapping here, basically we have kind of a test pattern-y look. I could change this to be that kind of a view. Basically, however you want your texture to look. All right, it could just be flat. The little lines aren't going to appear, but if you apply this texture, you will see this kind of a dice, well, not dice, like a checkerboard look. Decent for debugging textures, debugging objects, things of that nature. So let's play. So obviously our camera's not oriented yet, but you can see here's the light area, dark area, dark area. I'm going to leave it like this because this is my preference. You know, texture it however you would like. Let's also texture our ball. So what we can do, they don't do this in the tutorial. Let's do metal material. This is one way to take a standard demo program and make it a little bit more fun, is to add texture, add assets, things of that nature. Keep in mind that adding textures is going to bulk up your program's memory a little bit, depending on what you're doing, because you have to handle these assets. So I'm going to import these various ball texture, these metal textures here. I could probably more intelligently handle my folder structure too. But I'm just going to drop it into the materials folder. All right, about 20 minutes left, so I doubt we're going to get through the whole thing, but all right, so I'm going to click none because I don't want to import every single texture in here. But if I click the different mats, I get a little preview of what the object is going to look like. So I don't remember which one I liked. So let's do, kind of a, that's neat. It's very Metroid Prime-ish. That's boring. I have that in my other one. What do we got here? There we go. We'll go studded. So let's import pattern 21. So you'll note that this particular pack has a diffusion layer. It has a normal layer. So basically we're going to get a little bit of texture as well as a different view as well. So it popped up under metal textures pack here. Let's drag it into our materials folder. And then we have our pattern. Go back to our scene. I'm going to drag this pattern onto my player. So now my player looks cool. Look how cool that player is. Look at him. You also see here on the pattern that the mappings are actually automatically coming in. I could pick different maps if I wanted as well. So the various UV mappings coming in. All right, so our player looks cool. Our floor looks cool. Again, if you want to see what the camera can see without hitting play, just click game mode, and there you go. The rollerball tutorial actually has a nice setup where there is a scene view and a game view in the same screen, so you don't have to click back and forth, whatever your preference is again. All right, so we've got this, and then what else were we going to do? All right, let's rotate the light. So let's take the light and rotate it by 60 in the Y direction, just to offset the light a little bit. All right, so we textured our ball. So this is what I see in my other demo. I added this kind of wireframe view. You can actually see if you're in this particular project, you can actually see through the material, which is kind of cool. Like you can see the floor through the holes, which is nice. That's just how the patterns are set up. All right, we good so far? Everything makes sense? So again, all I've done really so far is I've created a plane that created a ball. All I've done is add texture and move the light around a little bit to be a little bit more pleasing for me. Directional light is here. Maybe we can move it up a little bit. Yeah, I can rotate it to be whatever I want to, right? So I can make it like a straight up shining. Can move it over here a little bit. Maybe we'll do that. All right, let's save our scene. And I hit play. Interesting, I don't see my ball. I'm moving the camera or the light. Let's reset the camera, or the light source. Move you up. What have I done? No. Did I screw up? Oh, I screwed up the I dragged the camera. That's what I did. Silly me. Let's not do that. All right, there's our ball. Light we want to mess around with, so rotation was 60. All right, there we go. That's better. Okay. Okay, so now let's control the player. So last class when we were controlling that little 3D guy in his nice little T-pose, we didn't really do anything other than use the default settings for that asset pack. What we're going to do is add a script to control the player. So I'm going to create a player controller script, call it player controller, and I'm going to apply it to my sphere, basically. So let's go over to our scripts folder here. We're going to add player controller, and I'm going to call it ball, just to differentiate it from the other project I've got open. I'm going to drag this onto my player. Hopefully that picked up because it just kind of lagged there for a second. Did not. So drag, apply. Script is here. Double click to open. And then we have our player controller. All right, so first things first, we are going to be applying forces to the ball. We're not necessarily going to be, again, moving the X and Z by itself. So we're going to use its rigid body, which we added before, and we're going to update that. So we first need a reference to that. So private rigid body is lowercase rb. RB, thank you, autocomplete. I wanted RB, not a rigid body. All right, so my local reference, and now I'm going to instantiate it. So RB equals get component rigid body. And assuming this compiles fine, I'm going to have a reference to my actual physics object. All right, so back here. Now what we're going to do is we're going to get the forces being applied from the arrow keys. So I'm going to get the force from the horizontal axis and from the vertical axis. So I'm hitting left or right or up and down. And then I'm going to apply that to my object. So this is where we get basically a vec3. So a 3D vector is going to be applied to the X, Y, and Z coordinates of the object itself. And you might notice in here that Y is 0. Again, it's not moving in the Y direction. It's moving in the X and Z directions. So, other thing too, we're going to add fixed update because this is a physics-based action that we're doing here. So we want float move horizontal. I'm just going to truncate that. Input a get axis horizontal. We'll call this vertical. All right. So we've got our directional forces here. Now we're going to create a vector3 in our C# language. So movement equals new vector3 move horiz 0.0f move vert. All right, one thing to keep in mind too, if you are working with magic numbers, basically, make sure that you tag them with the appropriate type. So 0.0f rather than 0.0 by itself, for instance. All right, so we have our movement. Now we're going to add a force. So basically we're going to add force, movement. Oops, not move vert, movement. Okay, so take the XYZ and multiply it by what our current position is. Basically, we're applying a force. Okay. So let's save. Let's go to Unity. If anybody can hear my kids screaming, but apparently something's going on downstairs. Okay, so we got a ball holding the left key. And we keep rolling. So, moved super slow. Camera didn't follow it. So those are two things that we're going to have to fix here. So what we can do to modify the force, modify the speed is let's just add a modifier. And what we're also going to do here is we're going to make it publicly accessible in Unity. So again, public float, we'll pop that up in the attributes editor, sorry, in Unity, so we can just change this as we go. So back here to our script, go up to our class variables. So public speed, we'll initialize it to, well, we'll leave it uninitialized, basically. What we're going to do down here in our movement is we're going to say movement times speed. There we go. This has to have a value or a type. Public int speed. Okay, let's go back to Unity. You can compile. Life is good. Click our player. And all the way down here, we see our speed variable. So if I just played this right now, we assume nothing's going to happen, right? So I hold down, hold right, left, nothing's happening, right? Because speed is 0. Let's change this to 100, just to get a feel for things. Whee! Woo! Very, very fast. Let's dial that back to 10. 10 should be fine. Nice smooth motion here. So if you got your 3D glasses on, prepare to freak out. Pew! All right, so we have a moving ball. Camera sucks so far, though. So let's add in the camera. Any questions so far at all? Hopefully should be fairly straightforward. At least I think it's fairly straightforward. Okay, so let's pop up private chat messages on the screen. That was a good idea. All right, so let's make our camera a little bit more intelligent. All right, so first we're going to position it a little bit better. So we're going to move it up by 10 in the Y direction, and then we'll rotate it. All right, so camera, move it up by 10, so in the Y direction, and then we're going to rotate it by 45 in the X direction. So now our camera is going to be looking at it from this top-down view. So if we go over to our game view, we have this nice little top-down. But it's still not parented to our object, or childed to our object. So if we remember from last time, all we have to do is drag this to whatever object we want to follow, and then we can see the camera moving with the ball. Whee! So the issue with this is that since we're a sphere rolling around, um, camera's also following us and rolling. So if we have motion sickness, I'm going to just stop that very quickly. That's not good. What we want to do is we want to add a script to the camera. So basically we're going to detach this. I'm just dragging it out. It's no longer a child. Um, basically I wanted to show that. The demo or the tutorial did that too, but um, it's kind of a good example as well. So we've detached and we're going to create a camera script now. And what we're going to be doing is that we're going to have an offset that we are going to basically create from the object itself to the player's position. And then we're going to call this update on late update. So basically calculate an offset from the player to the camera, and then apply that after all of our other updates have occurred. All right, so basically this code is going to give you that nice camera view that we want, and it's also going to follow the player around. All right. So what we have to do here, let's create a new script. So create C# script. What did I call this one? Player controller underscore ball. For you, because I don't want to deal with this. Create script camera controller. Thank you for that. Camera controller underscore ball. All right, this would be kind of a good little example of renaming as well. So open up the script. We see it in here. The name of the class doesn't match the file name, so I've just got to rename this. Basically, so camera controller underscore ball. So now it matches up. Unity started lagging on me a little bit. Okay, so again, we're going to need some class variables, and we're going to have to do some calculations here. So I'm going to need my variables here. So we need a public game object player. So what we're going to do is we're going to link up the player to the script so that we can get that object's properties. We're going to calculate our offset as a private variable because nobody else needs to know about this variable, not this action here. So then we're going to calculate it is going to be our transform position minus the player's position. Okay. And then update we don't care about for the script, but we want late update. Transform that position equals player that transform that position plus offset. So again, calculate our offset from the player to where we are at the start, and then just apply that every frame at the end of everything. All right, so that should be all we need there. So we'll save that, make sure I didn't screw something up. I will say I'm very shocked. It's an hour and a half into class and I haven't broken too many things yet. Usually I figured this would have gone a lot worse. Okay, so we have our script. It's good. It's not going to be able to pick up the player though, so we have to drag the player onto our... Please. Oh, have to be in the scene mode. Sorry. Not sure what I'm doing here. So player, don't have this accessible. Camera needs the player object. Where is our script? Oh, this is fun. I said I didn't screw up the stream, and I didn't. So the camera doesn't have the script attached. So first we attach the script to the camera, and then we attach the player to the camera. All right, did that make sense? Sorry, one moment. Had to move a baby monitor outside. All right, so what we did, as I was kind of digging around there, so I had to attach camera controller to the camera, attach the player object to the camera script. So that's what we see down here. So now when we save this, when we run this, assuming that I don't have a typo or a misplaced operation, the camera should follow fairly decently. So yeah, there we go. And we can fall off the world and die. So moving camera, very, very nice. And maybe what we will do too, so let's move the camera up a little bit more. So maybe make it 15. Get a nice little higher view since we made our plane so much bigger than it needed to be. Oh, there we go. All right, so what we will probably do then is we'll add some walls and we'll probably end there, is going to be my guess. So we have our ball, we have our floor, and now we need some walls to interact with, right? So we're going to create a wall game object. So what we're going to do is we're actually going to create an organizer. So I'm going to create an empty game object, and I'm going to put all of my, basically all of my walls inside of that object. So let's zoom out here. I'm going to create a new empty game object. I'm going to call this walls, just to organize things. All right. Then I'm going to create a new 3D object, cube, and I'm going to drag it inside this walls game object. So basically, I effectively have a folder in here. And I could access all walls in this way. I could add tags, as we'll talk about next time, or actually probably the time after. So we will call this one, I think the first one is west wall. So we have a cube that exists. It's way down here. Life is not necessarily good for this cube. This is where we want to reset it to origin. So reset. I guess that is origin. Interesting. Are you not at origin? Oh, players at origin. I want walls reset to origin. Reset. There we go. So now our cube is inside of our sphere, which is not good. Actually, if we try to play this right now, some interesting things will happen. Oh, interesting in that we have a little pedestal we're sitting on. Depending on your cube, so if we move this guy up, let's move you up by 0.5. The ball is either going to get flung out into outer space or it's just going to be kind of nudged off. So the way I've got it set up, it just gets nudged. If I pull this left or to the right a little bit here, yeah, so it just gets shot off a different way. But that's not what we wanted. We want this at the origin. All right. So reset to origin, very, very important. So we're going to create a rest wall. We're going to reset it, parent it to the wall object, and then we're going to scale it. So what I've got here is x is 0.5, y is 2, z is 20.5. So basically we're making a very long and thin type of wall with some height as well. So this one is 0.5, 2. Let me reset the frame here so that we can see it all right. So 0.5 and then 2 height and then 20.5. So we have a wall. Neat. Its position is still at the origin though. We don't necessarily want that. So we want the position to be -10 for x. So let's shift it over that way. All right, so we have a wall. What we're going to do now is I'm going to duplicate this. Let's call this east wall. And instead of -10, put it at +10. And I have 2 walls. Cool, cool, cool. Cool, cool. Now, we'd obviously do the same for the other 2 walls as well. You could either rotate it or you could change the size of it. So what we're just going to do is change the scale. Let's call this one north wall. Oops, I want to duplicate. North wall. So what I'm going to do is just I'm going to move this 20.5 into X, and Z is going to be 0.5. And my Z is going to be 10. X is 0, Z is 10, and then I have a wall that's been placed over there. Last but not least, it's probably actually the south wall. So our coordinates are off, so we'll call this south wall. This is now -10. Right? So now we have a walled garden. Add some flower pots off the asset store, and you've got a lovely little environment. These cubes have colliders applied by default, if you remember. So they will interact with the sphere collider on our ball. You see it doesn't have a super nice bouncy characteristic. We could add that if we wanted in our collider function, but we're not going to right now. So we have a nice little walled garden there. Let's actually move our light source up a little bit and rotate it so that we make our scene a little bit brighter. No, it was ready to go and I wasn't. All right. Actually, let's move our camera down a little bit too. Move you back down to 10. All right, so we have our garden. So I think we'll call that good for today. What we're going to be building up to is a fully featured ball roller, and we're going to add in some fun stuff too. So again, the plan for Thursday is we'll have our first student presentation, which I'm very excited about. And then we will do a lab. And then Tuesday, we'll finish up the ball roller and some procedural generation as well. I guess based on how much Kyle goes into with procedural stuff. Any questions from you all from today? All good? Alrighty. Then I hope you all have a wonderful and healthy stay-in-place isolation time. Like I said, if you guys have any questions, I'll be online. Feel free to follow along with me with this. Honestly, it is so interesting to be able to take this and apply it to other projects. So like for instance, I've been talking about this procedural generation thing. I'll show this off a little bit early. I took some C# code that I found on the internet for doing cellular automata generation for dungeons, and I just slapped it onto this rollerball demo. So basically I created a 3D dungeon world with a cellular automata generated environment. You see it's a little bit choppy. This is kind of what I was talking about with WebGL and optimization. This is, I think, a 200 by 200 environment. These are all trying to collide with my ball at the same time, so not necessarily great. But kind of neat what you can do with some of these like little tutorials. You can get something up and running very, very quickly. We'll look at the code of this guy too next time we have class. Anyway, I will see you all Thursday. Have a wonderful day. Bye-bye. Ending soon. Stream ending. See you guys.